Hello and welcome back to another VMK in the game development series. This video is going to be an introduction to our parser, which we're going to be developing in the next set of videos that are coming up. Now, the parser is going to be tedious. I'm going to tell you up front, parsing anything is really a bore to program. It's very repetitive, there's a lot of minute details you have to take care of, and computers really are dumb, so if you don't tell them to do something specifically, they're going to assume something, and if you forget to tell them how to do it, your parser is going to break. Now, the parser that I created, I have it working now, but there may be bugs in it still, so as I'm using it from day to day, I may be able to find things that I missed on the first run, so you have to bear with me. Now, the way that this video is going to work is I've put together this PDF document outlining the rules that the parser is going to follow, as well as the structure of the format that the parser is waiting to accept. So whenever you're creating this file that you'll be using to get parsed, you have to follow the rules inside this document. I'm going to go through this document in detail in this video, and then in the following video we're going to actually start programming. So there won't be any programming in this video. I'm just going to be describing how the parser is going to work and what kind of things the parser is looking for. This doesn't mean that the parser is limited. After going through all the different programming techniques and parsing things that are going to be outlined here, you should get a very good understanding of how the parser works. This will allow you to go and expand the parser to add any additional parameters, functions, anything you want into the parser. You can add that all yourself and expand upon it to make it even more dynamic, even better, whatever you want. This is sort of the lowest level that you can go and still have all the functionality that you need inside of the game engine. So let's get started. The parser itself is going to be an ASCII text file, which means if you open it up inside Notepad or any other text editor, you'll be able to read what's inside that file. It's not a binary file, it's actually an ASCII text file, so you can read it. Now, the extension of the file, I'm using .lvl, but you can choose to use whatever you want. I just chose LVL because that sort of looks like level to me with no vowels in the word. Now, what I've done inside of the game engine is I created a function called loadLevel, and you pass in a file name. So the file name that I pass in is going to be, I think, something like mission.lvl. And that's going to be the file that we create that's going to contain all the information. And down below inside this document, I'm going to show you the structure of the level file that you need to adhere to so that the parser can understand what's inside it. Oh, the other thing I should mention, this scene graph level format.pdf is going to be included with this video, so you don't need to really take notes. However, you know, make sure you go through, read it, maybe print it off because it is handy to have by your side when you are programming. Okay, rules to follow. Each line of the text in the file must begin with either a space, a carriage return, or a keyword, or a double slash. And the double forward slash looks like this. It has two lines pointing forward. This key is usually located to the left of the shift and is on the same key that the question mark is on. You'll have commands written on each line inside of this text file. If you leave a blank space, this is okay. However, if you add more than one or two blank spaces on a line, then the parser is going to complain and give you possible errors. So don't do that. You're only allowed one blank space on a line if you're going to use a blank space. Carriage return just means pressing the enter key, so you're allowed to do that. However, don't add like a bunch of spaces and then press enter. That's not allowed. The other thing you can do is add keywords. Now, when you're adding keywords, make sure that the keyword is the first word on that line. This is very important because the parser, when it's parsing through this text file, it's going to be looking for the very first word that it sees. And if it sees a keyword, then it'll handle it appropriately. If it doesn't find a word that it recognizes, it's going to give you an error and show you, I don't know what line 23 means, and so on. Each line of text should not exceed line max length. Now what this is, line underscore max underscore length, is a number that I've created inside of our code that is currently set to 300, and it specifies the maximum length of a line of text inside of this file. So if you're going to create a command that has a keyword and then a bunch of functions and something, make sure it doesn't exceed 300 characters. Most likely you're not going to reach this limit. However, if for whatever reason you're getting close to 300, you should go inside your code and bump this 300 up. And I'll show you where this 300 is located once we start going into the code. But for now, just remember, each line has a limit of 300 characters. Carriage return, pressing the Enter key on the new line, or a blank space followed by carriage return are used to add white spaces into the text file so that it is easier to read. What this means is inside of the level file, you'll have a bunch of commands, a bunch of code that the game engine tries to interpret. For you as the user, you want to sort of break this code up so that it's easier for you to understand what you just put inside here. And you can do that by adding blank spaces and carriage return. So you basically separate your commands out into separate groups. And I'll show you on the next page here what I mean by that in more detail. Multiple blank spaces on a single line are considered invalid, so don't do that. I mentioned that up here above. You're allowed to have one space and then press Enter. That's okay, but if you have multiple consecutive blank spaces, that's not allowed. You can add comments to the file itself, and you do that with the double slash. And this is helpful to label parts inside of your file, and I'll show you on the following page what I mean by that as well. So let's go take a look here. Here's an example of what a text file might look like. You would have double slashes, all geometry objects, and then a bunch of dashes to the end here. So this is a comment, and it's just saying everything below it is going to be geometry objects. And then here we have a bunch of geometry objects. So the first word on each line is the keyword. And later on in the document, I'll describe to you all the different keywords that I've defined. You can define whatever keyword you want, but these are the ones that I've just chosen. And then following the keyword, there's a couple parameters. And these parameters define how the specific object, geometry, material, whatever it is, supposed to behave. So here are all the geometries. Then we have another section here which I've commented out all materials. So I define the materials. Then we have all the textures. I define those. I have all the texture transforms. I don't have any defined here, but this is where they would go. And then we have a scene graph structure, and that's located here. And you can see I've added comments in between as well as white spaces to sort of separate out code. So you can see here I have a transform, and then underneath it, nested, I use a plus sign to nest objects underneath other objects, or shapes, or lights, or nodes, or whatever. So you put a plus sign, and then you have a keyword, and then the parameters. So then we have some boxes here. I have a plus sign, which means that this transform is nested underneath the original one here, transform, which is 0, 0, 0. And then double plus sign means that this light is actually nested underneath this transform here. So again, we have a bunch of boxes, and then we have a cylinder, and then the very last thing that the text file should contain is the word END in capitals. END is the last word that the parser is going to look for. So anything that you write underneath here will not get parsed, and you don't have to worry about it. You can write an essay underneath here, and it's not going to be a problem. But if you write an essay before this up here, it will be a problem unless you use the comments. So just be aware of that. The last thing that gets parsed is the end, and everything after that you don't have to worry. Okay. So now here's a little description of what this demonstration file here does. So use the top part of the file to list out all geometries, materials, textures, texture transforms that will be used inside the scene graph. As you saw, I sort of grouped them into their appropriate sections. Separate each category using comments and white spaces so that it's just easier to find inside of the file. Use the bottom part of the file to lay out the scene graph tree structure. The plus is used to nest nodes underneath another node, and the maximum number of nested steps is 32. So in other words, you can have 32 plus signs here to nest things 32 deep. However, if you do that, make sure that you have transforms that are located at the previous nested levels. So in other words, you can't just have transform here and then the one after that 32 pluses and then another thing. It doesn't work that way. You have to have transform plus transform, then plus plus transform, then plus 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 transform, and so on. You have to have a defined structure in a specific order for the nesting to work. Okay. At the end of the file, include the keyword end to notify that there is no more data beyond this point. You can place whatever you want after the line with the keyword end on it, and the parser will not read it into the game engine. So this is a good place to store unused scene graph structures or to put extra comments into your file without having to use a double slash. What this means is, for instance, let's say here, I created this level which has a bunch of boxes in the cylinder, but for whatever reason, I didn't want these boxes to be displayed on the screen. Well, what you could do is go in here and put double slashes in front of every single line of text here. However, to save you some time, what you can do is just highlight all of this code here and cut it and paste it underneath the end. If you do that, you don't disturb the structure. If you need it, you can cut and paste it back above, but you've saved it inside of the text file so that you don't lose it. If you ever need it, you can just go and repaste it back up here. But if it's located underneath the end, it's not going to get parsed. Now, keywords and options. The following keywords are allowed in the file format. Look at the way in which I program the code inside the scene double quote parser line if you wish to add your own keywords or options. So whenever we go inside of the scene class and start programming, you'll notice that I create this function called parseLine, and what it does is it basically takes one line of text from this file and parses it. And as it's doing this, it basically interprets what this keyword is, how far it's nested, what the parameters are, and so on and so forth. If you need to add your own keywords, you would put them inside of this parseLine function. So just be aware of that. Each keyword must be at least 3 characters in length and should not exceed 24. The reason why I say this is because inside of the scene structure, I create a variable that's of size 25. So if you create a keyword that's more than 24, it will overflow that variable and will crash your program. So don't exceed 24. If you want to use long keywords, fine. You just have to increase the size of the variable that contains the keyword. But I've chosen 25, which means do not exceed 24. Also, keywords and options are both case insensitive, so transform with a lower t is the same thing as transform with a high t, as well as mixed characters inside of the word transform. All of these are equivalent and the parser will not know the difference. All options must be followed by an underscore and then a value. And you can see that up here. You'll notice that we have a keyword here, for instance shape, and then we have a parameter called GOID, and the value is 1. So in between these there's an underscore, and inside here there's another one, matID underscore 1. So anytime we have an option, we need to separate it with an underscore. Integers must be whole numbers, in other words no decimal spaces, which means if you need to pass in an integer, make sure you don't add a decimal space. Have it just as a whole number inside of the file. Floating point array numbers must be separated by commas with no white spaces. Characters must have no white spaces as well. So in other words, if, let's see here, okay, let's take a look here at the transform. We have a translation value of 0, 0, and minus 2.5. So this minus 2.5 says that it's a floating point number. It could be also minus 2 if you wanted, that's fine, because all 3 parameters for the transform translate is actually a floating point number. So it's okay to have a decimal point. But if the parameter itself has to be an integer, make sure you don't add a decimal point like 1.0, because the parser is going to complain and it's not going to understand what that means. So be aware of that. Also, translation here is X, Y, Z, and you notice that each of these parameters are separated by a comma. Make sure you have these commas in here. Don't add white spaces. I have tested with white spaces and it seems to work okay so long as you put the white space after the comma but not before it. But as I recommend, don't add any white spaces and then you'll be sure to have no problems. You're not allowed to have any white spaces inside of text. So here for instance, the texture, you need to specify the file name you want to load. And the file name is located under Resources, Textures, barrel.tga, for instance. Well, if you had a directory structure that had a file stored where a directory had a space in it, you wouldn't be able to use this. So make sure that all your directories have no spaces in them, or else the parser will not work properly for you. Okay. No white spaces. Okay. And then the last thing here that I mentioned is this little heart symbol indicates that the keyword / option is required. There are certain keywords or certain options that must be specified by you inside of the file if you're going to use them. So be aware of that. Not all of them have required parameters, but some of them do. And if they do have a required parameter, you have to specify it. If it doesn't have the little heart symbol on it, you don't have to specify it, but if you don't specify it, then the default value will be used. And inside on the following pages here, I'm going to show you what each of the default values are. Okay. So now, what are the keywords and what are the options that you're allowed to use inside of this parser? Now, it only makes sense to create a parser that supports everything that we've developed so far inside of the game engine. So that's what I've done. If you went ahead and created other kinds of geometries or objects or whatever, you may want to add your own keywords in here for the parser to actually interpret them as well. I've listed all the keywords that I support, or that I'm going to show you how to support, alphabetically, so they're not grouped in any sort of order other than alphabetical. First keyword is box, 3 characters, BOX. And if you use this, it's going to create a box geometry. It has one required parameter, and that's the GeoID. So you need to specify an ID number for this specific box that you want to create. And the box itself has 3 parameters. It has the width, the depth, and the height, and each of them have their own options. So if you use the depth, you use DEP underscore, height is HEI underscore, and width is WID underscore. So if you're going to use any of these, you're going to need to specify a floating point number after the underscore. And if you do specify it, then you just write in the value here. If you don't specify any of these parameters, then it's going to use the default values. And the defaults for all of them are 1.0. So you see that here. Now, this ID number that you specify here is a ID number that you want to use inside of the parser. It's not necessarily the ID number that the game engine is going to use inside its own engine. The ID numbers shown here are just for your own use. The way that it's going to get programmed is the game engine is going to use your ID numbers to figure out what it is you intend, but it's going to create its own ID numbers whenever it creates its scene graph. So make sure you understand the difference there. This ID number is going to be used as a reference to this geometry when using the shape keyword, and I'll talk about the shape keyword down below. So the next geometry item that we have here is a cylinder, and this keyword is CYL. And again, it has one required option here, and that's GeoID again. And oh yes, it's an integer value that you have to pass in, not a floating point, so which means you can't have a decimal point. And again, it's going to be the number that's going to be used by the shape keyword. And with the cylinder, we have 4 parameters. We have the radius, the height, the number of sides, as well as whether we want the cylinder smoothed or not. This one here is an integer. Same thing with the number. It's an integer. All the other ones are floating point values. And here again, I've listed what the default values are. 1 for the height, 1 for the radius, 20 is the default number of sides, and then smoothing by default is turned on, but if you want it turned off, then you would specify it to be equal to 0 here. We have the keyword end. It is required, so make sure you add it into every single file that you create. And there is no options for the end, it's just end, END, that's it on the line. Next keyword is grid. This creates the flat grid geometry. We have the GeoID once again as the required parameter, and we have the depth and the width as floating point numbers, and the number in X and the number in Z divisions that you can specify as well. We have the light that you can create, and what I've done here is the keyword light actually behaves for 2 different purposes. It behaves to create the light node as well as to create the light class that is required for the specific light source you want to create. So we have a required parameter, which is the type, and the type is a string of characters that you're going to specify. And the string of characters that are allowed are either the letters POINT for point light source, DIR for directional light source, or SPOT for spotlight source. So you need to specify which of the light sources you want to create. Once you've done that, then a number of these parameters may or may not be required, depending on which of these light sources you've chosen. Now, you could go ahead and specify all of them, and the parser is smart enough to know which ones to use and which ones not to use. So for instance, a directional light source has no position. So if for whatever reason you specified a position for a directional light source, that position is not going to generate an error message, it's just going to skip over it. The parser will know to skip over it. However, if your light source type is a point light source, then the position will matter, so the parser will extract the values that you've stored for the POS option here. Okay, let's just quickly go over what options we have. We have the ambient light source, color. We have the attenuation value. The attenuation is 3 parameters for linear, quadratic, and constant. So first it's constant, then it's linear, then it's quadratic. By default, the value is 100, which means it has a constant value of 1, 0 for linear, and 0 for quadratic. And here I also specify that attenuation is only used by point light and spotlight. So if you have a directional light source, it's going to skip over attenuation. Cutoff, angle in degrees for the spotlight. You can specify that. We have the diffuse color, we have the direction of the light itself, and it's only used by directional light source as well as for the spotlight. We have the exponent value, which is used by the spotlight. We have a name. The name is used for the node light class. So if you give it a name here, then inside of your code you can go and refer to this specific light source and do whatever you need to do with it. This is handy because what you may do is inside of the text file create some nodes, some transforms, whatever you name them, and then inside of the update, inside the scene class, you want to go and extract those names to find the specific nodes that you want to work with and then update them. So that's why we have a name here. We have the position for the XYZ position of the light source on, whether we want the light source to be turned on and off by default. And again, if you've named it, then you can go turn it off or on, whatever you need. Specular light, and then the type, which we already talked about. Okay, moving on. We have materials. The required parameter is mat ID, and it's an integer again. We have ambient color, diffuse color, emissive color, shininess, and specular color, all optional, so you can specify them if you want. You don't have to, and if you don't, then it's going to use the default values which are shown here. These default values are the same values we saw inside the constructors. We have the shaped node. For the shaped node, you need to specify which geometry is the shaped node for. So up here, for the different kinds of geometries we created, you specify a required geometry ID. As soon as you do that, then whenever you create a shaped node, you need to specify the ID number for that specific geometry that you want to attach to the shaped node. And the parser will automatically make the connection between that geometry and the shaped node. Material ID is not required, but if you did have a material that you created, you can attach it to the specific shape node. So you'd pass in this ID number here into material ID here. We have name, we have texture ID, and we have texture transform ID. We have the texture transform node. So here we have the required parameter for texture transform ID, as well as we have the center, rotate, scale, and translate as the 4 optional parameters you can specify. We have the texture itself. It has 2 required parameters, the texture ID, which is required, and the file name. You can't have a texture without a file name because all textures get loaded from a file. So you need to specify the file name. Remember, all file names must not have any spaces in them. So make sure that if you place the texture inside of a directory, your directories don't have any spaces in them either. You can specify whether you want mip mapping turned on or off with a 1 or a 0. The quality factor, again, remember we have 4 different qualities depending on whether we're using mip mapping turned on or off. So we have quality 1, 2, 3, and 4, so you can specify those. And solid. By default, it's set to 1, which means it is solid, but if your file has alpha values, then you want to set the solid value to 0 so that the transparency of the file is handled appropriately by the game engine. And finally, the last keyword that we're going to implement is the transform. And this is sort of the most important one, because this is the one that allows you to nest other transforms and other things underneath each other. There are no required fields inside of the transform keyword. Realize that because sometimes you may just want to place a transform so that you can nest something underneath it. So you don't need to specify any values, which will mean that this transform will have the default values that are shown here. If you do want to specify a specific angle, axis, center, scale, translation, or visibility, you can do that using these options here. So as you can specify a name for the specific transform so that as you're programming the update scene class, or sorry, the update scene function, you can refer to this specific transform using the name. Okay, so that's about it. There's a few keywords, not very many, but there are quite a few options for each of these keywords that we're going to have to implement. So I'm not quite sure how many videos it's going to take to implement all this code. It is a lot of code that we're going to be writing, but once we finish writing all the parsing code and everything's up and running, it's going to be sweet, because then we can go and just modify the text file and have different levels loaded into our game engine. And we won't have to recompile our program every time, because all the parsing will happen dynamically. So in the next video, we'll start coding our parser.